Good afternoon, we're Team Metric, and our Grand Challenge topic today will be clean water. The objective of our presentation today is to demonstrate the severity of the problem of providing clean water and present strides engineers have taken to eliminate it. In our presentation, we'll be covering what the Grand Challenge is in the background, an engineering solution, and the future impact and influence that it will have.
Freshwater resources available to humans today are referred to by scientists as renewable freshwater resources. Only about 2.5% of all water on Earth is freshwater, and the majority of that is stored in glaciers and reservoirs deep underground. However, humans still have access to about 45,500 kilometers cubed per year of fresh water, and we only use about 3,800 kilometers cubed per year of that, which is less than 10%. So there's plenty of water available to humans for us to survive, but the uneven distribution of water across the globe is the reason that water shortages are a problem. Because of this, about 2.4 billion people all over the world are living in water-stressed areas, and transportation of water isn't often practical.
So, the challenge is to provide access and availability of clean water for everyone in the world. A few problems that threaten access to clean water include the introduction of new pathogens and contaminants and growing populations and their demand for water. This has become not only a problem for the developing world, but also the developed world, due to a lack of infrastructure. Some statistics that illustrate the urgency of the need to provide clean water include the fact that 1 in 6 people don't have access to clean water, 5,000 children die daily due to waterborne illnesses or lack of access to water, and less than half of the population in many developing countries have access to clean water. The problems of providing access to clean water between developed and developing countries differ. In developed countries, the problems include a breakdown in infrastructure. Many of the pipes that were installed years ago had a 100-year lifespan and have outlived their lifespan. In developing countries, they struggle with water contamination from different sources, including human waste and agricultural waste, which include pesticides and other runoffs, and naturally occurring waste due to hurricanes and tsunamis. The need is to provide clean drinking water and water for agricultural and industrial use in developed and developed countries.
The majority of the water consumed by humans is applied to agricultural purposes. This makes the worsening water shortages an even bigger problem, as it could result in an expanding food shortage. As the climate worsens, more people are born, and hungry people demand more and more food. Both of these problems are going to be exacerbated even more. Although these are proposed solutions, there is no viable engineering solution in the short term for these, but they can include desalination, algae, and other simpler solutions such as reduction in water use.
The water seer is a sustainable, low-maintenance device that can provide water for entire communities. The water seer condenses water vapor from the atmosphere to provide pure distilled water. This process does not require any power or chemical input, making it ideal for remote and developing nations. The water seer has portions both above and below ground. There is a metal container below ground where the temperature is lower. The part above the ground contains a turbine which is spun by the wind. Although wind is not necessary to the process, it can facilitate it by directing it into the condensation chamber. Here, the warmer air cools and condenses and runs down into the collection chamber.
After being tested over the past 6 months, the water seer has a very simple construction and design in coordination with a very minimal maintenance plan, making it only cost about $134 when it hits the market, making it an even more successful piece of engineering as it's very financially viable for the long term.
The temperature difference between the air and the ground is always present, so the device is always functioning. The water seer can produce up to 11 gallons of drinkable water each day without the need for labor, electricity, or causing any adverse effects to the environment. Because the water is produced from condensing water vapor, regardless of the air quality, the water will be free from pollutants and impurities.
As of now, testing of the project by UC Berkeley has been very positive for the project and has been picked up by the Peace Corps for large-scale deployment in third world countries heading into 2017. In addition to the base model, Vicky Labs is developing a cold weather kit so clean water may be produced in Arctic temperatures where needed. Also, multiple water seers can be connected to a single or a few large reservoirs, forming orchards of water seers to collect possibly hundreds of gallons of water every day for a large area. As a result of these developments, the water seer has the possibility to be a prolific piece of engineering, a masterful translation of science into technology to tackle one of the biggest challenges of the modern world.
Due to the spread of waterborne diseases, clean water is a paramount challenge which may be tackled by the simplicity and ease of installation as well as the usage of the water seer. As a result, communities in developing nations may make critical water shortage a problem of the past. These are our sources we use for our research. Thank you.